In this video, I will be demonstrating how we can evaluate the definite integral. I will be doing 3 of these 4 examples and leave the last one as an exercise for you. So let's get started. In part A of example 11.2.3, we've got to evaluate the definite integral of a cubic polynomial function from 3 to 6. So the first thing we're going to do is we're going to start off with the antiderivative of each of the terms in the polynomial function. So I have 2x cubed, so I'm going to kick that up one notch. 2x to the 4 divided by 4 plus 7x would be 7x squared over 2 minus 3x cubed over 3 and plus 2x. Now I could add a c value here, but I don't need to. I'm going to have you think about why that is. But at this point I'm going to move on and think about why I don't need that c. And if you're having trouble with it, go ahead and pick a c value, put it in there, and continue with this process. And you'll soon find out why you don't actually need to include a constant. In fact, the constant that I'm choosing by not including a constant is really 0. Okay. Now, of course, all of this is going to be evaluated from 3 to 6. And so I end up here with, let's simplify a little bit, so that would be x to the 4 over 2 plus 7x squared over 2 minus x cubed plus 2x. Okay, from 3 to 6. Okay, now this is going to get pretty long-winded when I sub in 3 and sub in 6. So bear with me here. I'm going to write it this way. So I'll go 6 to the 4 over 2 plus 7 times 6 squared over 2 minus 6 cubed plus 2 times 6. Okay, so I'll write that out first, and then I don't want to encroach upon the space for part B, so I'm going to go subtract. Now I'm going to sub in 3 into each of these terms, minus 3 to the 4 over 2, I'll put that in brackets, plus 7 times 3 squared over 2, minus 3 cubed, plus 2 times 3. Okay, now essentially, I mean, I don't leave myself very much space down here, but I could really just punch all this into my calculator. Let me at least get a couple of values here. So in my calculator, this piece over here turns out to be, after all is said and done, I believe 570. Okay, so that's this blob right here, when you evaluate, is 570, minus the expression in the brackets. What we're subtracting here is 51, so the final answer is going to be 519. Okay. Okay, let's move on to part B. Maybe this is a little bit simpler, we'll see. I'm going to rewrite this as the integral from 1 to 8 of the function x to the negative 2/3 dx. Okay, that might make it a little bit easier to find the antiderivative. So the antiderivative would be x. If we add 1 to that, then we would get 1/3, and then we'd have to divide by 1/3, but dividing by 1/3 is the same as multiplying by 3. So there it is. Let me just quickly double check that mentally. If I take the derivative of this, the 1/3 comes down, multiplies by 3, cancels, leaves me with x, and then an exponent that is 1 less than 1/3. 1/3 minus 1 is negative 2/3. Yeah, that totally works. Okay, so we end up with, now with this one, because I have a constant out here, I could just box that out, leave the 3 out here, and just sub in the 8. So 8 to the 1/3 minus, let's sub in the lower limit, 1 to the 1/3. That equals 3 times cube root of 8 is 2, cube root of 1 is 1. So 3 times 2 minus 1 is 3. Okay, and we'll finish off with this third one, part C. Looks a bit complicated, but the key here is to do something at the beginning to make your life a bit easier, and that is, let's divide each of the terms in the numerator by t, which is the denominator. So really what I'll have here is I'll write this intermediate step. I have t squared over t minus 2 over t plus the square root of t over t dt. Okay. So let's simplify even further. So it's the limit from, or it's the integral from the limits 1 to 4. T squared over t is t, minus 2 over t. And I guess this would be plus t to the negative half. Okay, since this is t to the positive half, and this is t to the 1, and if we divide two powers of the same base, then we subtract the exponent, so this would end up being negative half. Okay, so I've come up with an equivalent definite integral. So now all I need to do is just take the antiderivative of each term. So the antiderivative of t is t squared over 2. The antiderivative of 2 over t. Well, do you remember what kind of function has a derivative of 1 over x? Yes, it's ln x. So the derivative of ln t would be 1 over t. So basically I've got 2 ln t here, right? Because again, ln t would be, the derivative of that would be 1 over t. So there's our minus 2 over t. And then this would be, what would it be? It would be plus t to the add 1 to that half divided by half, which would just be 2. Okay, and then all of this is evaluated from 1 to 4. Okay, so subbing in 4, I've got 4 squared over 2 minus 2 ln 4. Okay, I'll need my calculator for that one. Plus 2 times 4 to the half. Minus, in brackets, now we're going to sub in 1, the lower limit, into each of these terms. Minus 1 squared over 2 minus 2 ln 1 plus 2 times 1 raised to the half, or the square root of 1. Okay, so 4 squared over 2 is 8. Minus 2 ln 4, I'm just going to have to write it as 2 ln 4. I'm not sure what that is. It'll be some decimal. Plus 4 to the half is 2. 2 times 2 is 4. And then we're going to subtract. Let's see if I can squeeze this in here. This would be, let's see, half. This would be half, yes. Ln 1 is 0. So that whole term disappears. And then this would be plus 2. Okay, so maybe I can come up with an exact value for this. This would be 8 plus 4 is 12. 12 minus 2 is 10. Minus half is 9.5. So 9.5 is 19 over 2 minus 2 ln 4. I think at the end of the day, the answer is approximately 6.73. And so there's our answer. And we'll leave the last one for you as an exercise.